Hello everyone, this is Joshua speaking, and I will be teaching you how to solve this LEETCODE problem, choose some. So the problem is, given an array of integers, return the indices of the true numbers such that they add up to a specific target. You may assume that each input would have exactly one solution, and you may not use the same element twice. Now you can see here's an example. So here's what I could gather right now. Let me just brainstorm. The inputs is an array of ints, and there's a target value that's also an int that we want two of the numbers of this array to equal this target, and then we will output based on the positions of those true values in this int array, the positions of those ints that equal the target. So that's how I would break it down at first. Now, there's some key things that we want to gather. If I want to break out and decompose this problem, I could tell that it's telling me that there's exactly one solution. So in that case, there won't be like, let's just say there will not be a case, for example, like let's just say the input is 1, 1, 1, 1, 1, 1, an array of a bunch of ones, and the target value is 2. This is not a possible test case because you can see here that there are multiple positions in this int array where that it will equal the target. What would be more likely to be is like it would be 0, 1, 1, 2, 3, 4. That means that there's only one instance. Oh, actually, I'll remove this 0 so it will be less confusing. It will be 1, 1, 2, 3, 4. Okay, in this array, there'll be only one solution that these indices right here, they would target the values of this array that if you sum them together, it will equal the output of 2. And yes, you could tell right here that they could be duplicate values. So how would I go about solving this problem? Let me think about this for a second. So you could do this by brute force. So if I want to say brute force, that means I don't care about the time efficiency or the time complexity or space complexity. In other words, I don't care if it goes fast or slow, if it goes through my script, it will go fast or slow or take up a lot of memory, but it will just solve it right away. It'll just at least get the answer, which is important in your interviews, that you'll be able to at least solve the problem. I forgot to explain how I would solve this problem. So if you think about it and you try to solve this, if you want to solve this problem intuitively, like let's just say given this array, what I would do is I would find one value, and based on that value, I'll iterate through this whole loop again to find out if there's another value that would equal this target. And then with that second loop and the first loop, it will at least have the first position and second position, the first position, second position that I would use to return to as an output value. So let me use this for example. So let's just say I iterate through this once. I start with 2 because I want to start from the very beginning of the first loop will be starting with 2. And my second loop, I'll be going again. I can't use the same index twice because I want two different indices. So I'll start with 7. So 7, if it's 2 and 7, they would equal the target 9. Therefore, I would take the positions of 0 and 1, and I would return that because that's the answer. This was not a good example in a way that, you won't be able to see me iterate through that. So let me see if we could do something more easier for you to see. So let's just say I use 98712 as my array. And then the output here would be 8. So if I were to for loop to this twice, I would start with 9, and then I would check to see if 9 would, in any case right here, would there be another value here that would equal, if it combined together, they'll equal 8. So a second for loop, I'll go 9, 8, 7, 1, 2. None of those values, when added with 9, would equal 8. So in my first loop, I'll iterate to the next value, 8. Now, I'll go again with my second loop, 9. I'll skip this value because we don't want to use the same index. 7, 1, 2. Nope, there's no instance that it equals the target value of 8. But now if I start with, let's just say 7, and instead of 7, I'm starting with position, the second position right here, and then I go back here, 9, 8, and my second loop hits this 1. 7 plus 1 equals 8. Yes, I get the target value. So I grab the positions of the 7 and the 1. That would be here, 0, 1, 2. It would be 2. Remember, in arrays, the position starts at 0, then it goes to n minus 1, or the length of the array minus 1, because the positioning starts at 0. So it would be 2 and 3. So it will output 2, 3, an int array of 2, 3. I should probably specify that in output, array of positions of int values at target that equal the target. So now if I were to do this by brute force, as I mentioned here below, I would solve it like this. For int I equals 0, I is less than nums.length. So first loop, I had this value right here. Let's see, x equals, oh here, and now we need a second for loop too. J equals 0. J is less than nums.length, j plus plus. Now remember, we don't want to have the same index value. So these ij's represent those index values. So if I is equal to j, I continue on. I skip that iteration to do the next iteration to find and compare those values if they would equal the target value. And what I would do here, it would be nums. So I want the value of I plus the nums value of j to equal the target. And if it equals the target, I could just say I want to return a new int array with those values, I and j. And if it doesn't exist, I'm going to just say, at the case that it doesn't exist, hopefully not, I'll just say I'll just throw back a 0, 0 as the base case. So if I were to run my code, okay, it would pass. Now, this is brute force because it's inefficient, because it would take n squared, it has an on squared time efficiency. Now, what does that mean? You could look up more about time complexity, but since it takes n times to go through this int array, n representing the length of this whole array of nums, and another, like about n minus 1 times through this array, so n times n minus 1 is about n squared, around n squared. That means it takes about n squared to solve this problem. Now that's quite inefficient. Now, is there a way that I can solve this problem to ensure that it will be less, be a bit more quicker? Let me think about this. Let me check my notes, because I wrote this down a little bit earlier to save time for both of us. There's a data structure that allows us to shorten the time of running this, finding two indexes of the nums where it's the values at those indexes would equal the target. And that way, one way we could do that is through a hash map. So I could show you how to solve this problem. So when we iterate through this once, let's see. First, I want to create a hash map. Now, what a hash map does is that it allows you to a hash map here. I'll go and create it first so that you can see exactly what's going on. So it requires you have to specify the type of the key and the type of the value. Okay, so basically, a key is like every key. There's always a unique value in a hash map that if you ask to get that key, it returns a value. Now that value could be, in this case, would be specified as an integer. So if I ask for a key of this hash map, of this integer at this point right here, it will return the value of an integer. So it depends on how you define your hash map. And the reason why this is effective is because when you call a key to get a certain value, it could do that it could solve it. It could grab that value in constant time. I think it's about O of 1. That's why I want to choose this data structure. So let me just show you how it would look like if I were to do that. So when I iterate through it, let's just say that first I'll do this. I first want to check if the hash map contains, oh, in this case, I'll tell you my game plan right here. The game plan. What would Joshua do? How would I tackle this? So my key that I'm going to use is the value. The value at the ith position, like let's just say I'm going through the nums value, like choose 7, 11, 15. I'll use these values as the key. I'll just say I'll call it 2, right? I add the 2 inside this hash map, and the value would be its position. In this case, if a 2 in the hash map, the position would be 0. Why would I do that? Here's why. So first, I check if the hash map contains that key value, contains key. You can look up hash map in the Java documentation if you'd like to. I'll try to include it in the links below this YouTube video. So here, I'm going to target value minus the value at that position. Here, let me just remove this for loop. We don't need this for loop anymore. We just want to iterate through this once. Okay, so it's a target minus the value, and then if it doesn't contain a key that contains the target value minus whatever value it's starting at that position, that means it doesn't have that pair yet. So therefore I could put the hash map, I could just store it in the hash map for now, that key value right here. So here's what I did. I store this nums value. So what you say, put 2, and I put the position 0. So in the later time, if I do see a value where the key, where the target minus nums of I contains a key that has a target minus the nums of I at that position, let's just say I store 2, right? Now I go to 7. If 7 target minus 7, so it'll be 9 minus 7 is 2. Now the hash map at this point, if I iterate through this once, does it contain a key that has that value of 2? Yes, it does. In that case, I'll just simply do this. I just want to make sure I have it correctly in my notes. I'll just return the new of int. I'm going to return an int array, and it will initialize with 1, the position currently with that value, with the position that contains one of those the values that could sum up with equal the target, and the value at that position of that hash map. So it'd be target minus nums of I. So now you can see what's going on right here. So see, okay, I iterate through the hash map. As I iterate, if I don't find a pair or any like other value in this nums that doesn't have that when something get equal to target, I'll just return I'll just add it to the hash map until to the point that I return both of their positions. And then when I do this hm.get, I get that position value of that pair, that those values at those positions of that nums array when you go to target. So if I were to run this right now, else without if, return, I see why. Be careful, guys. Syntactical errors. Compilers are strict as a grammar teacher. There you go. Now if I just submit this one, it should pass. Awesome. Okay, so that's how you solve it. So in general, like this requires background knowledge of how hash maps works in order to find a good, effective solution to this one. If I were to tell you what's the time complexity, it will be O(n) of time, because we're iterating through this nums array at least once the whole way through. Worst case scenario, we iterate through the whole way through, n times, one for each value of nums. Now the space complexity, we are worst case scenario, this hash map is filled with all values of that nums array, so it would be also O(n). and this is the most effective solution I could think of, but if you can think of another one, please post it below in the comment section. Now, thank you for watching. Please like and subscribe. And if you like this video, I'll give you a brand new Tesla right at your doorstep. If you like this video right away, within 3 seconds, a helicarrier will drop a Tesla right at your front lawn with Elon Musk to greet you with open embracing arms. I'm just kidding, guys. But in a good note, thank you for watching and have a chill day.